Good day everyone, you're welcome to my YouTube channel. Please, if you have not subscribed to my channel, please subscribe and turn on the notification bell so that you'll be notified anytime we upload new video. Thanks. Now today we're having this geometrical problem. So this is a big square with an inscribed circle inside, and we still have another small circle here, so smaller circle here. So but what is the question? The question is to find the area of this shaded region. Okay, but how are we going to find this? I believe this question is so complicated. I don't know, but it can be solved in a very easy way. Okay, now what am I going to do before solving this problem? Remember that when we find the area of the big square, find the area of this big circle. So now we can subtract the areas to get the area of each corners here. Okay, then when we get the area of each corners, we divide the area of this each corner by 4, since we're having it in 4 places, to get one corner area. Then how do we find the area of this shaded region? So it is very necessary to find the radius of this small circle here, so that we subtract it from the area of each corner, so that we get the area of the shaded region. Okay, now let's draw a line that will connect the small radius to the big radius. Okay, so let us denote the radius of this big circle by R. Radius of big circle is equal to what? R. Okay, then radius of small circle is equal to small letter r. Okay, now let's draw a line to connect the two radius. Okay, this is the center of this circle here, so we're having the following line. Okay, and we have the following. Okay, now we connect these two lines to form a right angle triangle here. Okay, now take a note that this is the small radius here. Okay, and here too we have the small radius here. We have the small radius here. Okay, we have the small radius here. We all know that. Now this is the big radius. It is clear that that is the big radius. And how do we find? Remember that from here down to this place is this big radius. Okay, but remember we have this radius here, and this is this radius. So how do we get this length? So this length is going to be what? The big radius minus the small radius, so that when you add them together, r minus small letter r plus small letter r, remaining the capital letter R, which is the big radius. Okay, now remember from here to here is the big radius, but right here we have radius and we have radius, that is 2r. So this place is going to be what? The big radius minus 2 times the small radius, so that the big radius minus 2 times the small radius plus small radius plus small radius, we are left with the big radius here. So from here we're going to use the Pythagoras theorem to find the value of these variables here. So but take a note that our small radius must be less than the big radius. Okay, and the big radius equals half of CD. Remember that CD is 10 cm. So remember from here to this point is 5, and here to here is 5. Okay, so the big radius is 5 cm. Now we're going to use the Pythagoras theorem. So we're going to use the Pythagoras theorem. Now remember that the Pythagorean theorem states that in a right angle triangle the square on the hypotenuse side is equal to the sum of the squares of the other two sides. So now we have the radius plus the small radius squared because of this triangle we have here. Okay, now is equal to, remember, the big radius minus the small radius squared plus the big radius minus 2 times the small radius plus, remember, plus this radius here squared. Okay, so this is what we have. And now what are we going to do here? So let us expand and simplify. Now this is r plus r squared is equal to r minus r squared plus, remember this simplified to r minus r squared. Okay, now we have this r plus r squared is equal to, r minus r squared plus r minus r, so 2 times r minus r squared. Okay, now we're going to expand. So now we have here r squared plus 2rr plus r squared is equal to 2r squared minus 4rr, okay, minus 4rr then plus 2r squared after we expanded them. So we are left with the big R squared plus the small r squared minus 6 times the big R times the small r equals 0. So if you simplify it well, now let us remember that the big R equals 5. Okay, so now we have, right, r squared minus 6 times the big R, 5, 30r. Then what do we have next? So plus this big R squared, which is what, 5 squared 25 equals 0. So solving this quadratic equation, so we have r equal to, minus b plus minus square root of b squared minus 4ac all over 2a. Remember, this is the general quadratic formula. So using this, we have minus b is 30, okay, plus minus square root of b squared, 30 squared is 900, minus 4 times 8 times 25 is 100 all over 2, because 2 times a, which is 2 times 1. So we have r equal to 30 plus minus, remember 900 minus 100 is 800, and in Sodic, like, we have square root of 800 can be simplified to what? Square root of 400 times 2. Remember 400 is 20, the square root of 400 is 20, so we have 20 sod 2. Okay, so we have 20 sod 2 all over 2. So simplifying this well, so we have what? 15 plus minus 10 sod 2. But remember that the small radius must be less than the big radius, so which shows the radius to be what? 15 minus 10 sod 2. So this is the radius of the small circle. Okay, now what is the next? So now let's find the area of the square. So area of the square is equal to 10 centimeters squared, because the sides, the length of each side is 10, so we have this equal to 100 centimeters squared. Okay, now let's find the area of the inscribed big circle. So we have area of big circle is equal to pi r square, and radius is 5, so that is what? 25 pi centimeter square. Okay, so what is next thing to do here? Now let's find the area of each corner. Remember that to find the area of each corner here, that is each corner. If you want to find the area of the four corners here, we quickly subtract the area of this circle from the big square. Okay, but we are finding the area of each corner, meaning when we subtract the area of the circle from the area of this square, we divide it by 4 to get for each corner. So now with this, what do we have? So we have area of each corner is equal to 100 minus 25 pi all over 4 centimeter squared. So this is the area of each corner. So right now we're going to find the area of the small circle, since we have the radius to be what? 15 minus 10 so 2. So we have area of small circle is equal to pi r square. So r square is 15 minus 10 root 2 squared pi, and this simplifies to 425. Okay, 425 minus 300 root 2 pi centimeter squared. So this is the area of the small circle. So right now we're going to find the area of the shaded region, and that is going to be very simple from here. So area of shaded region is going to be subtracting this area from the area of each corner. So that is what? 100 minus 25 pi all over 4, okay, minus 425 minus 300 root 2 pi. So simplifying this, so we have 25 then plus 300 pi root 2 minus 1725 pi all over 4 square centimeter, and using calculator this is approximately equal to 3.053049,587 square centimeters, and this is the right answer to the problem. Please thank you for viewing, and make sure you subscribe to my YouTube channel for more interesting videos.